Hello there and welcome back. Tonight we will gently explore one of nature's quietly astonishing phenomena, O-negative blood, a precious and rare universal donor type, often referred to as the lifesaver that can help almost anyone in need. Imagine yourself in a calm, softly lit laboratory filled with a sense of gentle wonder as we begin this soothing exploration of what makes O-negative blood truly exceptional. To start, let's kindle a sense of relaxed curiosity about blood and the reasons it holds such profound significance for our bodies. Blood, as you may recall, transports essential nutrients and oxygen to cells, along with aiding in immune responses and waste removal, yet it is also intricately organized into classifications known as blood types. Each type is determined by the presence or absence of certain molecules on the surface of red blood cells known as antigens. In the ABO system, which is one of the essential ways we categorize blood, individuals can have type A, type B, type AB, or type O. Another layer involves the right factor, generally denoted as either positive or negative, depending on whether the right antigen is present. With O-negative, there are no A antigens, no B antigens, and no right antigen on the surface of these red blood cells, creating a unique immunological footprint. Because of the absence of these major surface markers, O-negative blood typically does not spark unwanted immune reactions when transfused into individuals of other blood types. This is why O-negative blood is referred to as the universal donor type, capable of helping virtually any patient in an emergency. When someone's life is on the line, especially in sudden or severe traumas, there might not be time to precisely determine their blood type. In those dire cases, O-negative blood is the dependable choice. It can be given to individuals who are A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative, without posing a high risk of immune complications. Now let's take a calm breath and continue to delve more deeply into the tranquil science behind these antigens. In general, the ABO categorization relies on the presence of sugars on the red blood cell surfaces. Type A cells carry N antigens, type B cells carry B antigens, type AB cells carry both, and type O cells carry neither. Meanwhile, the right factor is determined by a separate protein. If you are right positive, you carry the D antigen, which is a dominant trait, and if you are negative, you lack it. Being O negative means your red blood cells have none of these distinguishing markers, which in turn explains why O negative donors are so crucial in emergency medicine. For individuals with O negative blood, their plasma can still contain antibodies, those of the ABO system, because these may be present in the liquid portion of the blood. But when used primarily for red blood cells, donors with O-negative blood are in a class of their own, able to provide a safe transfusion to nearly anyone, which can quite literally make the difference between life and death in a life-threatening situation. Picture, in your mind's eye, a single droplet of O-negative blood under the microscope, illuminated by soft ambient lighting. Within that droplet, red blood cells glide gracefully along in a calm, rhythmic dance, carrying an invisible potential that can save countless lives. Because they do not have A or B antigens, they are not recognized as foreign by the immune systems of recipients who might have type A, B, or AB. Because they do not have the right antigen, negative recipients do not perceive them as a threat. It's almost like these cells were made to be accepted universally, carrying a subtle but extraordinary gift. The molecular structure of these cells, free of both ABO antigens and the right A antigen, provides a truly unique flexibility in transfusion medicine, one that healthcare professionals heavily rely upon, especially in times of urgent need. Despite its universal donor status, O-negative blood remains quite rare, found in only about 7 to 9% of the population, yet it accounts for an often disproportionate share of blood transfusions, because it can safely be given to so many. Consequently, hospitals and blood banks frequently face a consistent need for O-negative donations. Donors of this blood type find themselves in high demand, as their contribution could be the deciding factor in someone's survival, particularly in crisis settings where medical staff may not have a moment to run compatibility tests. This is what makes repeated blood donations from O-negative individuals so incredibly valuable. Their life-giving blood can be dispatched in moments to treat newborns, trauma casualties, individuals undergoing emergency surgeries, and those with compromised immune systems who need immediate transfusions that pose minimal risk of rejection. Let's drift deeper into a peaceful reverie of scientific details. While a broad swath of humanity benefits from this universal donor type, the science behind genetic inheritance of O-negative is equally fascinating. In many ways, the inheritance patterns revolve around which version of the ABO gene and the right gene you receive from your parents. Each of your parents passes down one ABO allele. If you inherit the O allele from both parents, you become type O, since O is recessive to both A and B alleles. For instance, if your mother has type A, likely AO genotype, and your father is type B, possibly BO genotype, there is a chance that each parent could pass on the O allele, resulting in you having type O. The negative status arises if both parents pass on the recessive negative allele, because the dominant right positive allele will typically overshadow the negative one. Two negative alleles must come together for you to be O gene negative. Therefore, O-negative results from a double recessive ABO genotype, OA, and a double recessive right genotype, a less common outcome in large populations, but not so rare that we never encounter it. You can almost imagine these traits flowing quietly from generation to generation, waiting for just the right combination to manifest as the universal donor. Some families carry more O-negative members strictly due to these genetic coincidences. From a purely biomedical perspective, that would seem like a minor quirk, but given a situation where a single donation of O-negative blood can be used to help the majority of people who need blood at that moment, this seemingly small genetic coincidence can blossom into a gift of extraordinary magnitude. As we remain immersed in the gentle hum of this explorative journey, let's shift our focus to the significance of blood transfusions throughout history. Before the ABO and right systems were properly understood, attempts at blood transfusions often ended in tragedy due to mismatched blood types. When Austrian physician Karl Landsteiner first discovered the ABO system in the early 1900s, it revolutionized modern medicine and opened the door to safer transfusions. Later, the understanding of the right factor further refined that safety by explaining why some transfusions would still fail, even among ABO matches, particularly in pregnant women, whose bodies might respond to fetal blood if they were RIDES incompatibilities. The presence of the universal donor type eased concerns in critical times, ensuring that O-negative could provide a safer fallback when type-specific blood wasn't immediately on hand. The phenomenon of universal donation is still updated and refreshed with ongoing medical research, but the fundamentals remain astonishingly consistent. O-negative, lacking all major antigens, can be accepted by many. Of course, for routine or non-emergency transfusions, doctors will always prefer to match the recipient's exact blood type whenever possible, as supplies of O-negative often need to be conserved for those should the unexpected arise. However, the fast-paced environment of trauma care doesn't always offer a chance to do extensive typing, and that's precisely where O-negative steps to the forefront of life-saving intervention. Now, as you relax and let the knowledge envelop you, consider the preciousness of each tiny red cell. Each donation of O-negative blood can be separated into multiple components: red blood cells, plasma, and platelets, each fulfilling a different function for patients. In urgent care, the red blood cells are often the most direct route to stabilizing someone who has lost a significant volume of blood, helping to restore the body's capacity to carry oxygen. Plasma from O-negative donors, while not universally transfusible in the same way as their red cells, can still be indispensable for individuals who share or match certain compatibility markers. Furthermore, platelets, which help with clotting, can become critical for patients with bleeding disorders or those undergoing certain chemotherapy treatments. All this underscores the versatile importance of each O-negative donation. Picture that serene laboratory once again. There is a sense of soft tranquility as medical professionals quietly check donation bags, each carefully labeled with the O-negative designation, storing them in temperature-controlled spaces. The hum of a cooling system might fill the background as a gentle reminder that blood must be cared for, tested, and meticulously matched whenever feasible. Yet this single classification, O-negative, is the emergency hero. Even newborns in the most delicate states can receive O-negative with minimal risk, making it vital for maternity wards and pediatric units as well. To fully appreciate the scope of O-negative's influence, imagine stepping into a calm emergency department. Often paramedics arrive with severely injured patients. If these individuals lose large amounts of blood, there is neither the time nor the capacity to determine their exact blood type. Medical teams will often reach for O-negative because it is presumed to be compatible with everyone. This can be a lifesaver before further lab testing allows for a precise match later. The ease and safety with which O-negative can be administered reduces the critical time gap in life-threatening situations, providing an invaluable buffer. Now let us explore why, beyond acute trauma, O-negative might also appear in other areas. Certain medical treatments, like organ transplants or complex surgeries, can sometimes require immediate or large volumes of blood on standby. The more prepared a medical facility is, the better their ability to cope with unforeseen complications. That readiness extends to collecting and stocking O-negative blood. As a result, many blood donation drives especially encourage O-negative donors. In some regions, we even see specialized messages reaching out to these donors, acknowledging the unique power of their blood and urging them to donate whenever they can. Since O-negative is a minority among blood types, that supply can get depleted rather quickly. Like a gentle wave of relief, we see how each donation extends a lifeline to people across all walks of life. As we proceed through this relaxing journey, let's touch upon something that might give us deeper insight into the magic of O-negative. Beyond a BO and ROC, there are in fact over 300 additional minor blood group antigens known to science, although these seldom cause major issues in urgent transfusions. However, in extremely rare circumstances, patients can have specific requirements even beyond a BO and ROC compatibility. This is why blood banks will often do extended typing on donors, especially those who donate regularly, to find precise matches for individuals with uncommon antigen profiles. Despite these complexities, O-negative remains paramount because it skirts the largest hurdle, O-ROC mismatch. This ensures that in the broad majority of cases, O-negative can be safely administered. Returning to our tranquil discussion, you might wonder about how blood is screened and tested to ensure safety. Modern blood donation processes involve gentle needle insertion, collection into sterilized bags, and thorough testing for infectious agents. Blood centers will also confirm blood type, including ABO and RUG status. For O-negative donors, that label of universal donor is carefully verified time and time again. There is a sense of reassuring calm in knowing each unit of blood is handled with rigorous checks before being approved for transfusion. In many countries, technology has advanced to a point where donors can even be reminded digitally of when their last donation was used, though specifics vary. By the time these donation bags reach a hospital's transfusion service, everything is in place for swift administration if needed. Picture that moment, a quiet beep of a monitoring machine, the hush of an emergency room, and a professional carefully retrieving a bag of O-negative blood from refrigerated storage. Volunteers' combined generosity flows forward in this single unit of blood, bridging the gap between life and unthinkable tragedy. It represents the outcome of a serene chain of events, from the donor's willingness to share this rare resource, to the meticulous handling by healthcare workers, and finally to the waiting recipient. In such instances, O-negative becomes more than just a label on a bag. It is a tangible testament to the collective effort of medical science and compassionate humanity. Now let's shift our focus gently onto the personal side. Some O-negative donors may not fully realize how much of a difference they make. They may come in for their routine donation, settle into a comfortable position, and calmly watch a small vacuum tube fill with that cherished resource. In that moment, it might seem like an ordinary act, spending a half hour or so donating blood. Yet behind the scenes, entire procedures are lined up, ready to place that donation into the hands of healthcare providers who stand by at the crossroad of life and death decisions. In this sense, O-negative donors play a quiet but vital role in sustaining the healthcare system. They provide the safety net that every hospital relies on. And because the ABO and RUG systems are deeply rooted in how our bodies identify what belongs and what does not, the lack of these antigens in O-negative holders becomes a beautiful twist of fate, granting them the power to help nearly anyone else, regardless of that person's recognized blood group. This soft sense of altruism, woven together with science, builds a heartening story that carries on at every donations lab around the world. Drifting further in our peaceful reflection, let us also consider how genetics shape the occurrence of O-negative differently across populations and ethnic backgrounds. In some regions, the O-negative percentage might be slightly lower or higher than the global average, but overall it remains a small fraction. In turn, each donation from O-negative individual holds that much more importance in communities where it might be in low supply. Healthcare providers often speak about the volunteer donors of O-negative as hidden heroes, even though these donors themselves may see their genetic inheritance simply as a neutral quirk. Yet that quirk can mean the difference between seamlessly providing a blood transfusion and scrambling to locate an alternative. There is a kind of grace in that universal acceptance. The intricate mechanics of the immune system, which typically serve to keep our bodies safe, can also create barriers when trying to share blood across different types. Through a remarkable stroke of biology, the standard ABO and RUG recognition pattern does not get triggered by O-negative red cells. Subtle differences at the molecular level, like the simple absence of certain sugar-based or protein-based markers, yield tremendous results in real-world situations. Imagine if you looked at those red cells in a super close-up view, each one shaped like a small biconcave disc, lacking the major surface antigens that typically provoke an immune response. Step back a bit, and we see the entire AB and ROC system as an interplay of inherited traits that has shaped medical practice for decades, leading to trending calls for more O-negative donations in blood drives. And step further, we grasp that these systems highlight the web-like connections that remind us how one person's biology can collectively help us all. As you rest peacefully, you may also reflect on how, from a purely physiological perspective, receiving the correct type of blood is like seamlessly joining puzzle pieces inside the body. When the match is right, the body welcomes the red blood cells as if they were its own, continuing the cycle of transporting oxygen to tissues without interruption. When the match is off, such as when a person with type A blood receives type B blood, their immune system reacts, leading to a transfusion reaction. But O-negative bypasses that mismatch. While it isn't perfect in every context, for instance, in non-emergency settings, we still strive to perfectly match the recipient's type. O-negative stands as the safest immediate option. Its universal donor status is a defining feature, celebrated in clinical medicine with a gentle sense of awe. Consider the synergy of the AB and ROC grouping again. Because ABO-negative individuals lack the E antigen in the ROC factor, their donation stands out as a kind of baseline standard for emergent usage. In contrast, AB positive sits on the opposite side of the spectrum. EB positive recipients can typically receive red blood cells from a AB or ROC group, which is why they are known as universal recipients. So if AB positive is the universal recipient, you can think of O-negative as the universal donor. Two fascinating extremes on this continuum of immunological compatibility. Our softly spoken journey inevitably circles back to the vital role that O-negative plays in saving lives. The reason we speak about it in calm reverence is that, in the throes of crisis, time is of the essence. The ability to administer O-negative blood without hesitation can be the difference between reversing catastrophic blood loss and losing a precious life. It's remarkable how an aspect of biology as subtle as an antigen's presence or absence can have such far-reaching implications. In effect, O-negative is the molecular hero that quietly waits on hospital shelves, ready for an unknown moment that could arise at any second. Take a moment to imagine the quiet hush of a pre-dawn hour in a hospital. When a sudden call comes in, a patient with major injuries is being rushed in, and there may not be time to type their blood. Nurses and doctors rally around, prepping for transfusion, and inevitably those precious bags of O-negative appear, bridging the gap until further tests reveal the exact blood type. This universal donor stands at the front line, offering hope in a moment that is often chaotic and unpredictable. In reflective calm, we can also appreciate the deeply human side of O-negative donation. Many donors will over time recognize the significance of their contribution and feel encouraged to give regularly. Blood centers often remind these individuals that their specific type is special, that it is in high demand, that by maintaining their donation schedule, they are effectively participating in a life-saving mission. It draws a line from the microcosm of biology to the macrocosm of human life. Each drop, each bag, and each transfusion connect countless people in an invisible chain of survival. In a sense, O-negative donors carry a gentle superpower that can bypass the protective immunological boundaries of countless recipients around the world. No matter a person's AB or classification, they can receive O-negative red cells when time is short and minutes, and so the cycle continues. Universal donors quietly offering a portion of themselves that can sustain life in dire times, tranquil instruments of compassion. As you rest, you might think about how the entire system of donation, testing, distribution, and transfusion is laid out to ensure the preciousness of O-negative is safeguarded. You might think of the many dedicated healthcare professionals watching over the supply chain, the phlebotomists who collect the blood, the lab technicians who analyze it, and the transfusion medicine specialists who coordinate its deployment. Behind each participant is the unwavering understanding that O-negative can be used by anyone, reinforcing its position as a cornerstone in emergency preparedness. We can gently reflect that for all the complexities of the human immune system, the reason O-negative can help so broadly is precisely that its cells are free of the major antigenic markers. We do not need hype or dramatic flair to appreciate how extraordinary that is. Indeed, the quiet marvel of biology is that something seemingly so simple, the absence of certain surface proteins, has such a profound impact in saving lives. And while many might drift toward large-scale phenomena when they think of science, there is an equally breathtaking power in these microscopic wonders that unfold. Eventually, every donor, whether O-negative or otherwise, has the capacity to. But O-negative donors stand at the intersection of genetics and medicine in a way that underscores how a unique fraction of the population can benefit the entire spectrum of humanity. By its universal acceptance, a single donation can feasibly go to any patient, bridging gaps that might otherwise cost precious time or resources. In a time when precision and quick decisions are paramount, the presence of O-negative is a testament to the synergy of nature and science, nurtured by the generosity of those who roll up their sleeves and donate. Allow yourself now to rest in the knowledge that you have journeyed through the essential facts of O-negative blood, from its fundamental molecular basis, absent of AB and Ra contigens, to its role in emergency medicine and its inheritance patterns. We have explored how these genetic traits are passed down, how crucial O-negative is in emergencies, and how it is cherished by healthcare systems everywhere. We have let our minds wander through serene laboratory settings, imagining the red cells themselves in an almost meditative dance, traveling to save unknown recipients across a wide swath of humankind. You have learned how these donors provide an irreplaceable service, often without fanfare, and how these universal donors serve as a vital cog in the wheel of modern medicine. In essence, we have uncovered a story of synergy between the random distribution of genes and the structured approach of science, blending seamlessly to create a resource of immense value. May this reflection on O-negative blood soothe your thoughts, knowing that somewhere at any given moment, a tiny bag labeled O-negative stands ready to extend life to someone in peril. As our gentle exploration draws to a close, let these comforting truths settle in your mind that among the remarkable processes in our bodies, the capacity to share our blood and save another is one of the most selfless gestures proven by biology. Let a sense of calm envelop you, reassured by the existence of O-negative donors who bridge the divide between uncertainty and hope, carrying an invaluable gift in each cell. And let this contemplation lull you into a peaceful rest, content in the realization that science and generosity meet in these vital droplets, a quiet wonder that deepens our respect for the marvel of life. Thank you for joining me on this soft journey into the science of universal donors and the wonder of O-negative blood. May the comfort of this knowledge guide you gently into restful sleep, and may you carry this calm reassurance with you. Good night and take care as you drift off, surrounded by the peaceful thought that there is so much quiet goodness in the world, quietly waiting to help in the very next moment of need. Sleep well.